me see. I am probably what I'm going to do is I'm going to sit in front of my slides. That way, I'm going to share it this way. Can you? Okay, great. I can share. That's awesome. Okay, part of the screen. Share. Yes, that works.
Okay. It's yeah. But it's okay. Yeah, nice. Yeah, I can see that.
Okay, good. And I'm going to use my, yeah, this way I can see both users and I can see the chat and I can see everything here. So let's do the chat too, which I'm going to move here. Yeah, I want to do that. Maybe.
So hi, Eric.
Hey, Mohamad, how are you doing?
Yeah. Is that your normal lecture in Harvard? The
It
picture?
was my, yeah, it was my old lecture. I'm going to move this a little bit. Sorry.
Yeah.
I'm going to adjust it here. This is, I'm going to end with, what I'm doing now, which is, has progressed since then. Yeah, I want to be sure that I can see people, I can see the chat. So I'm going to put this here and then participants. We have 9 participants.
No, we wait for the.
I won't be alone.
Nice.
And let's see. Am I co-host?
Yeah, I think.
Breakout rooms. Yep, I can make breakout rooms. Fantastic. Okay, include co-host. I leave the co-host out so you can decide where you go. And roughly how many participants do you expect? Do you have a sense?
When I send the Google Calendar, it's about 80.
80.
Yeah.
Okay. So I'll make 12 breakout rooms. Okay, great. I can, oh no, I should not create them now. Yeah, good. So I think I'm good. I'm going to turn off my video and I'm going to turn off my audio. When you start and mention my name, I'll appear out of nowhere.
I'll start in another 10-12 minutes. I'll start off with your bio and from there we'll pick up.
Okay, so we start at 54?
55.
55.
Yeah.
Okay, wow, usually it's, after the hour, but you start before the hour. Okay, great. I'm going to take a quick mental break because it's the end of a long day for me.
Yeah. You do look a bit tired, yeah.
Okay,
Thanks,
see you.
bye. Yeah.
I'm here. And Nazri, you have my WhatsApp, yes. So
Yeah.
we can, where do I
Yeah, I
have?
can communicate with you. If we're ready, I send a message to you.
Yeah, that would actually be great. I'm
Yeah.
actually going to put WhatsApp open. I'm going to put WhatsApp on my screen too. WhatsApp. There. Oh, it's already open there. Oh, no, we don't want this thing.
You don't want to see that.
No, why does it jump like that? And we don't want ChatGPT on there too. Now I'm losing everything I want to show. Where is it? Oh, I have 2 WhatsApp open. How did that happen? Okay. All right, so if you text me, your chat will be at the top.
Okay.
Okay, I'm going to stop sharing. That way I can organize my windows.
So Eric, now
Yes.
you are more on lecturing in Faculty of Education or in Physics department?
I do not teach in the Graduate School of Education. I have, helped people cover classes, and I've given lectures in the Graduate School of Education, actually quite a few, but
Recording in progress.
but my focus is really in physics and in applied physics. So I have three departments:
Okay.
applied physics, which is in the School of Engineering; physics, which is in the Faculty of Arts and Sciences; and then I'm also associate faculty in the or affiliated faculty, or a member of the faculty, I think that's what it's called, in the Graduate School of Education. So those are my three hats. I have three bosses.
Yeah.
I can always say somebody else is the boss. Okay, good. So let me get this aligned again here. And
Yeah,
now
wait for the participant to join.
okay, good. Okay, great. So I'm going to hide myself.
Yeah,
And I'll be back
I will let you know.
in 9 minutes.
Yeah, I think, Nazri will let you know, that's better. Morning, ladies and gentlemen. We wait a few more minutes for additional participants. Today's session is special because Prof. Eric Mazur will have breakout rooms for lecturers to teach how to teach. Okay, so we wait a few minutes. Also, he has requested that participants introduce themselves in the chat room. He would like to get to know everybody because there will be breakout rooms later on. I see some interesting names. Mr. Michael Intia, Juan Paulo Hurada, George Palada. Where are you guys from?
I think they have some participants from Philippines. Yeah.
Quest Elaine, Jeffrey, Ili Salwani from UKM.
Yeah, we have some of the, not even, not from UNIMED, also it's from others university in Malaysia.
Okay, there's Park Shen Chung from MMU, Quantum Information. Sohana from UTM. Nice. Thanks for joining. UTM. UTM, then you should be very familiar with Eric. Yeah. Oh, Eric said yes. Okay. All right.
So people now join. I think we have around 58 now.
About almost 60, yeah.
Yeah. It's 9 p.m. in your place, right, Eric?
Yes.
But
Yes.
yeah.
This is the fun part of a long work day. Because I'm in the middle of my semester, so.
Okay. Susie from Malaysia, technical writer.
Yeah, we have some participants from University of Rizal System, Philippines.
Suzainur. With interest in communication training for STEM students. All right. Jeffrey from QIU. Rizal, Philippines. Okay.
The Quest International University is a private university. I think where's the location? I think in Perak, right?
Near Tech Park, I think.
Where is
Good
it?
morning. Hi, I'm Jeffrey from Quest International University. We are a private university in Ipoh, Perak.
Oh, Ipoh. Okay. All
Yeah.
right.
Depot where? Which country?
In Malaysia?
In Malaysia.
Oh, Indonesia.
Malaysia,
Oh,
Malaysia.
that's
Malaysia,
great.
Malaysia,
Yeah.
Malaysia.
Oh, Malaysia, not Indonesia.
North
Okay.
of about 200
Kuala
kilometers
Lumpur.
north of KL. Yeah.
I see. There were some people from the Philippines. Hello,
Yeah.
Lisa. Hello, George. I'm stopping to type this. And this is a whole delegation. Oh, no, they added notes. I see.
No, not delegation. Yeah. So I think I'll start off. Nazri?
Yeah. I think
All
we
right.
can start. Yeah.
Okay. My video is on, audio is on. All right. Everyone can hear me clearly. Salam sejahtera, selamat Hari Raya Aidilfitri, selamat pagi, and a very good morning to all gathered here virtually. We are here for Cosmos of Curiosity, Series 29. We thank Faculty of Intelligent Computing, University of Malaysia Perlis for hosting the Zoom. their respective offices and broadcast control team here, led by Mr. Shahrizan for this event. I'm Prabha, moderator come participant for this Series 29. Before we begin, as is normal, I would like to introduce our esteemed speaker for this Series 29, Prof. Eric Mazur, who will depart from our norm and conduct a sort of class on making classes come alive, curiosity as the engine of discovery in science and engineering, which is targeted at present lecturers or teachers as well as would-be educators in the near future. So let's all welcome Prof. Eric. Eric Mazur is the Balkanski Professor of Physics and Applied Physics at Harvard University and a faculty member at the Harvard Graduate School of Education. He previously served as Academic Dean and Area Chair or Dean of Applied Physics at Harvard's School of Engineering and Applied Sciences. He's also Chair of the Optical Foundation and past President of Optica. Mazur earned his PhD from University of Leiden in Netherlands and joined Harvard in '82, becoming a tenured faculty by 1990. He's a prominent physicist known for his work in spectroscopy, light-matter interactions, ultrafast lasers, and nanophotonics. He holds honorary doctorates from several international universities and is a fellow or member of multiple prestigious scientific organizations, including the Royal Academy of Sciences of the Netherlands. Beyond research, Mazur is an influential educator who pioneered peer instruction, a widely adopted interactive teaching method. He has authored over 380 scientific publications, 52 patents, and several books, including Principles and Practice of Physics. He has also founded multiple companies such as Psionics, Black Silicon Technology, Learning Catalytics, which was acquired by Pearson, and Perusol, a widely used social learning platform. Mazur is an acclaimed speaker and consultant, recognized globally for his contribution to both science and education. Today's session has quite an interesting abstract, and it goes like this. I once thought I was a good teacher until I realized my students were simply memorizing material rather than truly understanding it. The question was, who was to blame? The students, the content? In this session, I will share how I came to the painful realization that the real culprit was my teaching approach. I will also demonstrate how I adjusted my methods to improve student engagement and performance, and how to leverage innate human curiosity to make classes come alive. So, and with that, if anyone wishes to ask anything, I think we can do so in our compartmentalized breakout rooms of 5 each. We wish you a very good evening, Prof. Mazur. Before we begin our education, would you like to say anything?
Well, I'm going to say a lot because I'm going to be the one speaking for a while. So I'm going to say a lot, not.
The floor is yours.
Yes. Well, thank you. Thank you so much. It's really a pleasure to be here. As I put in the chat, I've been to Malaysia quite a few times and enjoyed my visits very much. I have a fond place in my heart for Southeast Asia and Asia in general. I go at least every year once to Asia, and sometimes multiple times. When I was president of the Optical Society, now called Optica, I think during that year I made something like 9 trips to Asia. That took a heavy toll on me. Anyway, I thought that since we are talking about education, I would essentially start with a small reflection, and I'm going to share my slides a little bit differently than what I did. Than I did before. I'm just going to put myself in front of my slide. Do I show up in front of my slides now?
Yes, you do.
Good. Okay. Terrific. So I thought I'd start with a short reflection, and I would like all of you to essentially take a little piece of paper, something you can write on, or a Word file or a note on your telephone, because I'm going to ask you 2 questions and I want you to commit to the answers and write them down. Don't put them in the chat because, I don't want everybody to see the answer. Plus, whatever you write there is, private to you. So you don't want to share it. Here's my first question. I want you to think about something you are good at, something you do well, something that other people are admiring you for. It could be anything. It could be photography. It could be writing novels. It could be managing people. It could be solving partial differential equation. It could be baking cakes. I'm just saying something here. But ideally, I want you to write down something that has been important in the development of your career. So I don't think we have any bakers here, professional bakers here in the audience. So baking will probably not be on the list. So I'm going to give you a few seconds to write that down. And it doesn't have to be a paragraph. Just write down enough so that you remember which, skill or knowledge you consider yourself really good at. I've done this in many academic places, and usually when I ask this question, it doesn't take long for somebody to raise their hand and say, only one thing? I know we're all good at many things, but pick one thing. Does anybody want more time? Yell or say, yes, I need more time in the chat. Okay, this is not too hard a question. The next question, however, and you can hide whatever you wrote down. Nobody needs to know what you think you're good at. The reason I had you write it down is because my next question refers to whatever it is that you wrote down. The next question is, and this is a much harder question, how did you become good at whatever it is that you wrote down? How did you develop that knowledge or that skill? I can't see you, unfortunately, but I know from experience that when I ask those two questions in a live audience, well, you're a live audience, but you're just live online. But if I do it in front of people I can see, when I ask the first question, everybody immediately starts writing, the heads bent down and they start writing. When I ask the second question, everybody, how did I become good at this? And the reason is that when we're good at something, we enjoy it. It's a positive reinforcement. And we become completely unaware of the learning. So you have to think hard. How did I develop that skill? Or how did I develop that knowledge? What were the circumstances that led me to become good at whatever it is that you wrote down? So think hard, dig into your past, and write down what helped you develop that skill or that knowledge. What were the circumstances that led you to become good? What did you do to become good? All right, and again, you don't need to write a whole paragraph, okay? And just a few words to jog your memory, because I'm going to poll you. In fact, maybe then I'll quickly design a poll if I can do that so quickly. This is so annoying. So every month or so, Zoom changes all its menus around, so I'm not even going to bother. I'm going to do it the old-fashioned way. Okay, so does anybody need more time? If so, put in the chat, need more time. If I don't see that in the next few seconds, I'm going to go and poll you. I've done this in many, many places, and I've collected the answers, not to the first question, but to the second question. And they tend to fall into 5 different categories. And if I were able to see you, I would ask you to vote by putting your hand on your chest and indicating with your fingers. This is a trick you may want to remember for when you're in front of your students. If you ever want to do an impromptu multiple choice question, one way would be to ask, how many of you have choice 1? How many of you have choice 2? But A, it becomes very difficult to compare the number of different answers. And 2, people are a little bit like sheep. And, you know, if a lot of hands go up for a certain choice, they also go up. So it's not a good way of doing it. But if you let everybody put their hand on their chest and you have the number of fingers, like I'm doing here now, indicate their choice, you can ask everybody to put their hand on the chest at the same time. And you can get from the people you're near a pretty good sense of the distribution of answers. I tell my class, by the way, if you do not put your hand on your chest when I count to 3, I will come to you with this microphone and I'll put this microphone right in your face and you have to tell the whole class how you vote. Quickly, they put their hand on their chest and they vote. But the great thing about voting this way is that it remains private, right? People who are sitting behind you can't see how you're voting. But as instructor, you can actually see them. Anyway, we're not doing that now, which is perfectly fine. So the answers that people give fall into the following 5 categories. I became good at it by trial and error. Trying things, making errors, trying again, improving, and so on. I became good at it by listening to lectures, or maybe watching YouTubes in the 21st century, who knows, right? The word listening is not on the screen there. Can you see, or am I in front of the text?
You're blocking a bit.
I'm blocking a bit. Okay,
Yeah.
I'm gonna go a
You
little
got to
bit on the side.
go, on the side.
But anyway, the second choice too is lectures. And I don't mean giving lectures, right? Because we all know that if you give lectures, you actually improve your understanding significantly. That's not what I mean. I mean listening to lectures. 3, I became good at it by practicing, which is very close to trial and error. Or I became good at it from apprenticeship, which means working along with people who are more experienced. In the sciences and engineering in particular, I think a lot of graduate studies are actually an apprenticeship. We, professors in engineering and the sciences, have learned by working in a group, developing, building machines, measuring things together with others. So I think apprenticeship is actually an important part of education. And then there's a lot of other things that people write down, like family and this and that and the other. I want you to choose whichever number, 1, 2, 3, 4, or 5, 1 trial and error, 2 lectures, 3 practicing, 4 apprenticeship, 5 other, and then put the number that is closest to what you wrote down in the chat. Go ahead. There's more than one person in the audience. Okay. 3, 3, 1, 3, 3, 3, 3, 3, 2. Keep going. We have about 100 people online here. That's great.
And 2 hours.
3. Awesome. Look at that. I'm going to wait a little bit more here. Hey, I'm going to put 4 because 1 through 5, I like that. And remember, you need to answer with respect to whatever it is that you wrote down, right? This is not in general how you learned anything. I became good at whatever it was that I wrote down. Okay. Okay, so, what I forgot to tell you was that, I've done this all over the world. I've done this in Chile, I've done it in China, I've done it in Japan, I've done it in Malaysia actually when I visited UTM. I have done it in Australia, all over Europe, all over, I mean, all over the United States and North, South, and Middle, Central America. And, there's something really interesting. There are big cultural differences between different countries and different people. But when you ask this question, there is hardly any difference. There's certainly no systematic and statistically significant difference between, let's say, China and Chile or Bolivia and Belgium, which first time was a little bit, or Saudi Arabia or whatever, because I've done it all over the Middle East too, and Africa. I forgot Africa there. Which just first surprised me. I thought maybe culture has an impact on learning, but then I realized, of course, that's not true, because the way we learned it's evolved over millions of years. It's sort of pre-programmed by biology in our brains. When we had the session with Carl Wyman and myself, we talked about that. And therefore, culture has a much smaller impact on learning than, the psychology, the cognitive psychology, the biology of the brain. And each time I do this, I think maybe that tonight I'll get an answer that is different, and I'll meet people who are actually different from the rest of the world. Well, if you think that you're different from the rest of the world, I have to disappoint you. You're not, because your answers are pretty much the same as the ones that I would get anywhere else on the planet. Look at it. If I scroll back here, you will see that 3 is in the overwhelming majority. There are some 1s. And there's something else that is really interesting about this distribution of answers. I'm a little bit surprised that there are so few 4s, but that's fine. That's okay. But there's something else that is really interesting. A very underrepresented choice is number 2. And why is that so strange? It's so strange because here you have just admitted that the way you learn is really by practicing or trial and error, which is more or less the same. An apprenticeship is actually not that different either. But how do we teach? This is how we teach. So you see, right off the bat here, you've just admitted that something that was actually important in your career, you learned it mostly by doing, not by listening to lectures. And you just have to step into any classroom anywhere in the world, and you'll see a scene that is pretty similar to the one that you see on the screen behind me here. This is actually a picture of me teaching. It's a very old picture. It was taken BC, before computers. I'm not that old, okay? You can see I'm still using an overhead projector there. Had just been appointed as, I think, assistant or associate professor. I didn't have tenure yet. And here I was teaching this class. And the reason is that when I was assigned to teach this large engineering pre-med class, so it was a mixture of engineering students and pre-med students, a physics class, you heard I'm a physicist, so I was teaching physics. And these were not students who wanted to learn physics. Oh no, they already hated physics before they set foot in my classroom. But and the reason I was assigned this class is that none of my colleagues wanted to teach this class because, pre-med students and engineering students are not very friendly to physics faculty. And typically at the end of the semester, when it came to the end of semester evaluation, the students in this class would give a very poor rating to the physics instructor. So I was the new kid on the block. So they said, Eric, why don't you teach this engineering and pre-med class? I didn't really have a choice, so I said, sure. And when I think back of when I started teaching, there's something really interesting. I never asked myself, the question, how am I going to teach? And that's kind of strange, because when you do something new in your life, then that's one of the first questions you should ask yourself. And even more ironic was the fact that I had actually a very negative experience in lectures. When I was 7 years old, my grandfather gave me a book on astronomy, and I fell in love with astronomy. The mysteries of the universe, the fact that there are these galaxies, there's the structure to the universe. By age 10, I decided I want to be an astronomer. So at age 17, I decided to enroll at the University in Leiden, and I declared astronomy as my field, only to discover within 6 weeks that it was nothing but equations written on boards. And all of a sudden, instead of talking about the big picture and the beauty of the universe, everything was about right ascensions and declinations. And I thought, astronomy is not for me. So I dropped astronomy and I switched to physics, only to discover that physics was taught no better than astronomy. It was just different formulas that were written on the board from one side of the board to the other side of the board. I was too afraid to switch major a second time, so I stuck in physics. And it was not until I joined a research group that I rediscovered the beauty of doing science. But anyway, by the time I had gotten my PhD and gotten to Harvard, and they asked me to teach, I'd forgotten all of that. And I started teaching by lecturing, as you see here. And something interesting happened. What happened was that all the signs that I received were very positive ones. How do we evaluate the success of teaching? I can think of two ways. One is the dreaded end of semester questionnaire, right? And I just told you that most of my colleagues got very negative ratings, but I got really high ratings, 4.5, 4.8 on a 5-point scale. I actually, because my colleagues got such poor ratings and I got higher ratings, I thought I must be a really good professor. I must be a really good lecturer. In fact, I very quickly started to believe that was one of the world's best professors. That turned out to be a complete illusion. So that was one thing. The other thing was exams. I'd had a pretty rigorous physics education in Europe. And in the US, I don't know how it is in Malaysia, but in the US, when physics is taught to non-majors, it's really taught without calculus. It's an algebra-based course rather than a calculus-based course. To me, that made no sense. After all, kinematics is calculus, so I just taught a calculus-based physics course to these non-majors. And I put on the exam some pretty tough calculus question that I wasn't sure I could solve under the pressure of time on an exam. But by and large, these students in my class did very well. So in short, they liked me as an instructor. They did well on what I thought were difficult exams. Obviously, I was doing the right thing. Now, I told you a minute ago that I never asked myself the question, how am I going to teach? And I didn't lecture them because I wanted to take, a vengeance on the next generation of students since I had a bad experience. No. That was certainly not it. I essentially projected my own experience naively. I thought, I have learned physics in a lecture. Therefore, that's how people learn. I mean, it's not a crazy assumption. It's only much later that I realized that I learned physics in spite of lectures rather than because of lectures. We'll get to that in a minute. And I think we all tend to do that. We tend to project our own experiences onto the world around us. And if we experience something, then we generalize that and we think this is how it happens. And I'm sure that my professors, my astronomy professors, for example, but also my physics professors, were thinking when they started teaching, I have learned it this way, therefore I'm going to teach that way, without even articulating it, subconsciously, of course. And their professors had done the same thing, and their professors are generation after generation after generation, all the way until this guy here. This is actually Heinrich VIII, king of the Emperor of the Holy Roman Empire and King of Germany, giving a guest lecture at the University of Bologna. And you only have to look very quickly at this and you see right away the sort of uncanny similarity to this 20th century, because this was before 2000. It was BC, but before 2000. And this picture, I mean, the similarity is amazing. I mean, we no longer wear those clothes that they wore back then. Although I don't know how it is in Malaysia, but in the US at graduation, we do wear those clothes just to remind ourselves how we have maintained medieval traditions. But look at it. The people in the front here, I don't know if you can see my cursor, are paying attention. In the back of this second row, they look a little bit bored. And then these two people in the back are having a conversation with each other. And then there's this guy here. I don't know. He's probably fast asleep in the back row. But I mean, it's just amazing how there's this incredibly similarity between a guest lecture given almost 1,000 years ago and lectures that are still taking place all around the world, including mine back in the early 80s, 1980s. So this is over 40 years ago. I started teaching at Harvard. Oh my God, 45 years ago. I'm getting old here. It's actually amazing. So I want to ask you a question. Look at this scene here behind me. How would you describe the activity that is taking place on the screen? I would like you to put that in the chat, and I would like you to use a verb. And there are two verbs I don't want to hear, teaching or learning or anything related to that. I want you to describe it in a different way. A verb, you get one or two words, but not more. So just blurt it out on the chat. I'm not going to say anything until I see some words. How would you describe what is happening there on the screen behind me? Passive. Engaging. Thank you, Sia. I appreciate that. Listening. Focus students. Focus. Explaining. Describing. Interpolating. Michael, I'm not 100% sure what you mean by interpolating. Sharing. Passive. Describing and sharing. Demonstrating. Watching. Now, there's something interesting about just about everything that has been written down so far. I'm going to wait another few seconds here. And the thing that is interesting about, keep writing, okay? The thing that is interesting about what is written down here is that they are all verbs that pertain either to them, the students, or to me, right? Listening, they're listening, but I am not. Guiding, I might be guiding them, but they're not guiding. Watching, they're watching, I can't watch them. Demonstrating, I'm demonstrating, but they're not demonstrating. Passive, they're passive, I cannot afford to be passive, right? I'd be, just standing there in front of the room, explaining, and then focused. Yeah, maybe we're both focused, but it says focused students. So, and then listening, again, they're listening, I'm not listening. So we're both in the room at the same time. So what is it that is happening? I'm starting to see some things that are a little bit more interesting, non-interactive and one way. One way what, Nazri? And others, please pitch in. One-way communication, but that's that's a contradiction in terms, right? Communication is, I tell you something, you tell me back. We're trying to communicate now through the chat, right? So what is one-way communication? It's like two words that contradict each other. So if it's not one-way communication, what is it? I'm having fun here with you. Broadcasting, exactly. It's a transmission, right? So very good, Paba. Excellent. So yes. In fact, I discovered it. I'll get to that in just a second. But what is it that is being broadcasted? What is it that is being transmitted? I'm asking you to write that down in the chat, okay? Information, knowledge, ideas, knowledge, theory. Okay, so let's talk about that. I mean, clearly we saw a number of information and a number of knowledge and a number of other words. So let's start with knowledge, because those are the words that I tend to hear the most when I ask this question in different audiences. So knowledge, ask yourself, is knowledge really something you can actually transmit? Is it something that can be transmitted? I don't think so. Knowledge is something that needs to be constructed in the brain of the learner. You need to connect whatever it is that you hear to your own experiences, to the own mental models. You need to build mental models in your head. It's not something that you can do by just sitting there and opening your skull and putting the knowledge in there. I mean, it'd be great if we could transmit knowledge. It'd be fantastic. Ideally, it'd be great if we could transmit knowledge when people are sleeping, which they're mostly doing when they're in a lecture anyway. And I think there's ample evidence for that. I can even show you some data. So I don't think you can transmit knowledge. So if it's not knowledge, what is it? In fact, some of you said it already. If it's not knowledge that can be transmitted, it's information. Lectures focus on the transmission of information, which can include theory, which can include thoughts, which can include opinions, which can include ideas. Knowledge needs to be constructed not in the brain of the teacher, but in the brain of the students. In fact, teaching is a very good way of constructing knowledge in the brain of the teacher. I've often taught more advanced courses because I wanted to learn the subject. And boy, do you ever learn the subject when you teach it. So as Aravina says there, lectures focus on the transmission of information. And you know what? I have to tell you this. My students had actually pointed this out to me. They taught, in the very first year that I taught, they told me that I was focusing on transmitting information. They didn't say it that way. I'll tell you in a minute how they said it. And instead of paying attention to them, I got furious. Let me tell you what happened. I have to go back in time. So I told you just at 10 minutes ago that when I started teaching, I never asked myself, how am I going to teach? But I had questions. The question was not, how am I going to teach, but type it in the chat, please. Not how, but put yourself in, my beginner shoes. And somebody, what exactly? What am I going to teach? So I knocked on the door of a colleague who had taught the course in the previous year, and I asked him that question. And he said, oh, Eric, in this class, we have used the book by Halliday and Resnick. Some of you may actually, if you've had a physics course, you may know that book because it's still it was already a classic by the time I taught the course, and now it's even more of a classic. Maybe I should say it's an antique by now, but it's still used by quite a few instructors. And then my colleague told me something that surprised me. He said, students are going to buy the book, and you have to be sure that the bookstore in Harvard Square has enough copies of the book in stock. This was BC, before computers, so it was definitely before the internet, and there were no online resource or anything. So it had to be a book, a physical book. So to me that came as a surprise, because in the Netherlands, where I was educated, you wouldn't buy a book. Why buy the book if the professor is presenting the content of the book to you? But anyway, I did as I was told. So 2 weeks before the course started, I went to, or maybe a month, I forgot, I went to the bookstore and I looked for the person who ordered the books, and I said, be sure that by September 15th, you have 150 copies of Halliday and Resnick in stock. And as I walked back from the bookstore to my office, I thought, wait a minute. If the students have the book and I have the same book, then, what's the whole point? So I started to get nervous, and I went back to my colleague and I knocked on his door and I asked him that question. And he said, oh, Eric, don't worry. There are lots of different physics textbooks. And he showed me a shelf full of books that he had collected over the course of his career. And I started looking, and very quickly, I found the perfect book. It was perfect for two reasons. One, it was different from Halliday and Resnick. And therefore, if I was using that book for my classes, I was at least not regurgitating the book that the students had bought. But that was not the important reason. The important reason was the book was out of print. They couldn't get their hands on the book. So for every class, I would spend, probably 10 hours developing a set of lecture notes. And in class, I would either write the notes on the board behind me, or I would project the parts of the notes on the overhead projector. And because my notes were a little bit different from Halliday and Resnick, I started with conservation principles rather than with Newtonian mechanics. Because of that difference, I thought it would be good if my students had a copy of my lecture notes. So just before the end of class, I had my assistant bring in, a set of 150 photocopied lecture notes, and she would put it at the back of the hall, so that when the students walked out of the lecture hall, they could pick up a set of those photocopied notes. Now, why do you think did I ask them, did I hand them out, at the end of class and not the beginning of class? Why? Please write it down in the chat. Wouldn't it make more sense to put it out at the beginning of class? They will focus on reading, attention. Students can focus on me, so they will listen to me. So they will not be disturbed by the notes. Maybe I should say it would be better if they read the notes so they're not disturbed by me talking. Anyway, isn't that ironic, right? I was worried that some would come in, pick out the notes and go back home. Or, indeed that they wouldn't be paying attention to me. But isn't that kind of selfish? I mean, why force the students to get the information out of my mouth if they could get the information out of the notes and, or the book or both? That thought never came up in my mind. But you know what happened? At the end of that very first year, when the evaluation came, there was, at the end of the evaluation questionnaire, there was a question which was a free response question where they could write a comment. And at the end of that very first year, about half a dozen students wrote in that comment section, Professor Mazur lectures straight from his lecture notes. Hello? I mean, what was I supposed to do? I'd taken those, made those lecture notes different from the book so that I wouldn't just be regurgitating the book. And now what did they want me? Did they want me to develop another set of lecture notes that was different from the lecture notes I lectured from? I mean, these ungrateful students, I was really upset. But they had a point. I was focusing on information transfer. And it was not until much later that I realized the irony of this all. 600 years ago, 601 years ago, Gutenberg invented the printing press, a phenomenal way of transferring information. Now information comes at us from everywhere, through books, through online books, through the internet, through ChatGPT, through video, through YouTube, you name it. Why do we still focus on a pre-Gutenberg approach to education around the world? It's absolutely mystifying. Anyway, as I told you, I was convinced that I was one of the best lecturers at Harvard, and maybe even wider because of my high ratings and because my students were doing so well on calculus-based exam. And it was not until much, much later that I realized that it was one big illusion and that students were not actually learning anything. Let me tell you what happened. I think it was after teaching about 6 years or so that I read an article in the American Journal of Physics that claimed that students who are not physics majors learn next to nothing in their physics courses. I read the abstract and I thought, not in my course. In my course, they learn. But the interesting thing was that the authors of that article had given a test to the students twice. Once at the beginning of the semester, the pre-test, and once again at the end of the semester, the post-test. And this test was essentially a simple word-based quiz that simply asked a set of, I think, 29 or 30 word-based questions that, in my opinion, were completely trivial, too simple to ask my students. But what was interesting was that in dozens of different universities in the United States, mostly in California, Nevada, Arizona, the difference between the pre-test and the post-test was almost zero. So in other words, students come in at this level, you teach them for 1 year, they come out at that level according to that test. And what was even more interesting was that the authors had looked at whether the rating of the instructor correlated with the gain, the pre to post-test gain. And the answer is no. The award-winning teachers did no better than those who were known to be dull, dry, and boring. In all cases, the gain was absolutely minimal. I saw this and I thought, just no way. Let me tell you the most difficult question, according to the data, on this test called the Force Concept Inventory. It deals only with the concept of force. And, I know I'm not here to talk about physics, doesn't matter, but I just want to give you an idea. Here's question number 15 or whatever it was. A heavy truck and a light car collide head-on the highway. is the force that the heavy truck exerts on the light car during the collision A, larger than the force exerted by the light car on the heavy truck? B, the two forces are equal to each other. In other words, the truck exerts the same force on the light car as the light car on the heavy truck. C, the light car exerts a larger force on the heavy truck than the other way around. Now, all students in an introductory physics course can recite Newton's third law. You may have heard about it. Action is reaction. In any interaction between two objects, the force that one object exerts on the other is equal in magnitude to the force that the other object exerts on the first one. In equation form, F12 is equal to F21. But according to this article, if you replace the 1 by truck and the 2 by car, students forget all about Newton's third law, which they can perfectly regurgitate on an exam. So I thought, this is totally crazy. There must be some kind of a disease raging in the southwest of the United States. In the northeast where I am, this is not possible. So it was unfortunately too late to do a pretest. We were close to the end of the semester, but I wanted to demonstrate that in my class, the students would ace this test. So I gave it. I told my students not to worry, that it was just, it would not affect their final grades. It would just be a good way for them to test their knowledge, and then I could help them improve their performance on the final exam, which was 2 or 3 weeks later. Well, let me tell you, they had barely begun this quiz, or one student raised her hand. I walked up to her, and she looked me straight in the eyes. And she asked, Professor Mazur, how should I answer these questions? According to what you taught me, or according to the way I usually think about these things? I didn't even know how to answer that question. I mean, shouldn't that be the same? I mean, I was totally flabbergasted. I didn't even understand her question. And by the time the test had been completed, it was clear that I had a major problem on my hands. Now, the last thing I suspected was really myself. So I tried to come up with all kinds of excuses. First, I thought, maybe I have dumb students, but, I teach at Harvard, and we have a very select group of students. We select sort of the top 0.5% worldwide. So it could obviously not be that. So I thought maybe I'm a bad teacher. But that could not be true either, right? I got these stellar ratings. They did well on exams. So put yourself in my position. What's another excuse you can come up with? I like that chat here, that buying the textbook sometimes feels like an extra side business for lecturers. I've used my textbook in my class, but I've given it away for free. I think it would have been unethical to make money from it. But anyway, so it can't be the students, they're smart. It can't be me because I'm a good teacher. What is it? I'm so proud of the excuse I came up with. Come on, be creative. It's not the student. It's not me. Why was the result on this test so shocking? Hey, I should be the one who's tired. It's late in the day. For you, it's still early in the day, so you're fresh. The test, yes, Prava, exactly. There should be something wrong with the test, Maybe that they're trick questions. I didn't realize that any physicist would have had no problem answering any. And if you ask graduate students or postdocs, they get most of the questions right. So, they don't trick physicists. And they're only dealing with the most basic part of the course, the Newton's forces, which I had skipped because most of my students come in was AP exams and physics background. So I thought, they already know about all of this. So I started doing some testing of myself. In the second part of the course, electromagnetics, I started to put some textbook problems and some really simple word-based questions that tested exactly the same concept, but one did it with formulas and the other did it with words. When I showed my colleagues these questions, they said, Eric, you can't put this word-based question on a test. It's too simple. It's too simple. My students overheated on the word-based questions. We made it the question number one for them to warm up on the exam. And it turns out, they had a lot of trouble with the word-based questions. What we considered an easy question, they thought was very hard because they couldn't rely on a memorized formula to solve the problem. So that's when I finally realized that the problem was actually that I had taught them simply to memorize, formulas, memorize approaches, memorize problem-solving procedures, but they were not really able to think. There was no understanding underneath it, which was, in a sense, precisely what had turned me off from astronomy when I was a beginning student at the University of Leiden. So that was a moment that I really, struggled. And I thought, maybe I should teach another course. Maybe this is not something right. But I thought about it some more. And then I thought, I really need to think about education, not as simply transmission of information, but as a two-step process. The first one is, of course, transferring information or broadcasting or transmitting, whatever you want to call it. But that's not enough. That's not enough. Students need to assimilate that information. They need to make sense of that information. They need to build the mental models that permit them to apply what they've learned into a new context. Have you ever, on one of your exams in your courses, tried to take something you've taught them and put it in a completely different context? What do students say when you do that? I know what my students would have said when I tried to do that. They said, Professor Mazur, we've never done a problem like this before. Well, I'm sorry if you had done this problem before, it would by definition no longer be a problem. So we're essentially drilling students to solve problems that can be solved much faster and much more easily by these devices. And we're not really setting them up for success in their later careers. And I don't know if you've read the recent articles in the press about the employment of graduates, at least here in the US, it is going down terribly. They end up being unemployable because they can't do anything that cannot be done by AI or a computer, because they've never learned to really think, to solve problems, to do things that are really important in the 21st century. So if you think about the traditional approach to teaching, we do this first step in class, and then we send the students home to assimilate the information out of class. I mean, this assimilation is actually the step where you go, oh, I get it. And ask yourself, where did it happen for you? Where did you go, oh, now I understand it? Was it while you were sitting in the class, with hundreds of other students listening to the professor? Maybe occasionally, but probably because you didn't have much time to think, you were mostly writing. And why don't you have time to think? You don't have time to think because, what is happening here? Sorry. Because essentially, let me turn on the lights. It's 10 o'clock and my home is thinking I'm going to bed. So let me turn on the lights. One moment, sorry about that. Okay, there. So there's no time to think when the instructor is talking, right? If you One instructor told me, if you start thinking, why is this? I was thinking that we're not good at multitasking. So we're thinking we're losing the information that is being transmitted. So we think, oh, let's just take a note and I'll think about it later. But for most of our students, that doesn't come. It worked for us because we had the discipline. We were intrinsically motivated to learn our field, and we continued to work after class on trying to understand it. Have you ever in your career, ask yourself this question, have you ever in your career as a teacher had a student raise a hand and say, Professor, can you please be quiet for 5 minutes? I need to think. Have you had that happen? I've never had that happen. But you have to admit, if you need to assimilate information, that needs to happen. So clearly, most of the assimilation doesn't happen in the class. It happens out of the class. So, I realized then that's what I should really focus on, because what is the easy, if we go back to this previous slide, which is the easiest of the two steps? Transmitting the information or assimilating that information? Which is easy? One or two? Put it in the chat. Well, good for you, Umawati, that they asked that. You should give those students a medal. I'm proud of your students. I am really proud of your students. Okay, 111, everybody says one there. So, it's kind of ironic that we take this precious time that we have as students to spend it on the easy part of education, especially now in the information age where information comes from everywhere. And if we're so good at lecturing, then why not record the lecture and have the students watch the lecture online? Or, and post it on YouTube and have them watch it. They can watch it and stop it and think, and they can continue it, and they don't have to do the homework. They can look at it when they want to look at it. So clearly that first step is not the hard part, it's the two. That's what we should focus on. So I thought, okay, I need to focus on it. And that's when I came up with the idea, let's flip this. Let's put the transfer of information out of class before we get to class. And then in class, I'm going to help students assimilate the information. So the whole flipped classroom movement actually started in 1990 in my class. I didn't call it, I called it the inverted classroom, and other people later came up with the flipped classroom movement, but that's where it actually started. I don't want to talk about this first step right now. We can talk about it later. I'm going to be done pretty soon. And I don't want to minimize it, but essentially in the beginning, I said to students, before coming to class, read this chapter in the book and read this chapter of my notes. And then in class, what do? I was thinking for a while, what am I going to do? And the answer to that question is actually nothing new. It's teach by questioning rather than by telling. Who was the first person who said that we should teach by questioning? It was not Eric Mazur. I can guarantee you that. Who was the first person to say we should teach by questioning? Socrates, exactly. Prabha, you get a badge for, being active on chat. Very good. Shout out to Prabha Karan. Yes, exactly. Now, it was not that I was sitting in my office thinking, what am I going to do? What am I going to do? Oh, Socrates. No, it was a completely serendipitous discovery. You see, after I gave that test to my students, the FCI, not only was I horrified, my students were equally horrified. And they knew that the final exam was coming up 2 weeks later. So they were worried. And they wanted me to organize a session where we would go over that test and discuss every single question. So I booked a large classroom in the evening from 7 p.m. to 10 p.m., a 500-seat auditorium. By that time, my class had grown to 250 students. And during those 3 hours, I went through every single question until I came to this question of the truck and the car. And I thought, it's such a simple question. It's just Newton's third law. Action is reaction. Force of truck on car is the same as car on truck. So I turned my back to them and I drew a free body diagram of the truck on one side of the board and of the car of the other, and the force of gravity on the truck, the force of gravity on the car, the force of the road that holds the truck up so it doesn't go to the center of the earth. Same for the car. And then I drew the force of the truck on the car and the car on the truck. And I turned around to them and I said, by Newton's third law, these two forces are the same. I could at once see from their faces that they were confused. So I said, is there a question? And they were unable, they were so confused that they could not articulate a question. You know how it is, right? So I thought, maybe they're confused by the fact that the forces are the same, but the effects are very different. The car is going to be obliterated and the truck is not. So maybe that they are confusing Newton's second law and third law. Newton's second law says F equals ma, the acceleration of the object, is related to the force by the mass. And because the truck has such a heavy mass, it's not going to have a big acceleration and therefore not change that much. So I erased the board and I started all over, and I gave the most brilliant explanation you could possibly imagine. Okay, by the end of those 8 minutes, the entire board was covered in equations, Newton's third law, Newton's second law. I'd worked out that even though the forces were the same, the accelerations were different. I mean, I was so proud. Of course, I'd done this all with my back to them, right? So after 8 minutes, I turned around. They looked even more confused. And they were still not able to articulate a coherent question. So I didn't know what to do. But I knew that half of them had given the right answer. So in a moment of despair, I said to them, why don't you just discuss it with each other? And something happened I had never, ever seen in my class. Complete chaos, okay? They all started talking to each other. They forgot about me in front of the class. I could have walked away. They would not even have noticed me walking away. And what was even more amazing was that in just 2 minutes, they'd figured it out. I thought, how can this be? I, the expert, have tried for 10 minutes to explain it to them in 2 different ways, unsuccessfully, and they just talk to each other for 2 minutes in pairs or, threes, and they figure it out. But imagine for a moment you have 2 students next to each other, Mary and John. Mary has the right answer because she understands it. John does not have the right answer because, he still has some mental obstacles in his brain. Mary is more likely to convince John than the other way around, simply by the force of logic. And I won't say this always works, but on average, it will work that way. Mary convinces John. But that's not the important point. The important point is this. Mary is more likely to convince John than Professor Mazur in front of the class. Why? Because she has only recently learned it. She still knows what the difficulties are that a beginning learner has. Whereas Professor Mazur learned it such a long time ago. To him, it's so trivial that he has forgotten his own struggles when he was first learning it. It's what my colleague Steven Pinker calls the curse of knowledge. We forget our own learning. And because we forget our own learning, we're unaware of how our students learn, what they know, what they don't know, and which things they can connect and which things they cannot connect. Susan Ambrose, in her beautiful book, How Learning Works, calls this the expert blind spot. And we, in our disciplines that we're teaching, all suffer from expert blind spot. Anyway, when I saw that chaos and how they explain it to each other in their own words, parallel tasking, right? Student A helps student B, student C helps student D. So, rather than one person trying to convince everybody without being aware of what the difficulties are. When I saw that, I thought, this is it. This is how I should be teaching. So now I don't lecture anymore. I give them something to read or something to watch. And then in class, I'll talk a little bit, much less than I've talked with you. I should have given you reading too, but that would have been unfair. And then I put a question up and I give them time to think. And it's quiet. They think. I tell them, you're not allowed to talk to anybody. If you talk to somebody else, I will come to you with this microphone here and I'll put it right in your face and you have to tell the whole room what you just told your neighbor out of fairness. And after I give them a little bit of time to think, I ask them to vote. There, I take a poll. I have to think how I'm going to take this poll here because I don't see you, so we can't do the hand trick. And I want to keep the poll private, so we can't use the chat either. I didn't think about that. I could quickly set up a Mentimeter, but we'll see. We'll figure it out. Okay, so I poll. Ideally, I try to arrange it in a way that my question yields about half of the class correct answers and half wrong answers. Somewhere between, let's say, 30% right answers and 70% right answers. Why? Because if there's less than 30% right answers, there are not enough students who are able to explain it to others. If there's more than 70%, students are going to turn to each other and they agree on the question. And then they're going to do something else. They're going to pull out their phone and they're going to look at their phone. So that's why I go between 30 and 70%. If it lands between 30 and 70%, I tell them, turn to a neighbor, try to find a neighbor with a different answer, and try to convince that neighbor that you are right and he or she is wrong. Chaos. And then after a few minutes, I poll them again. And if you start with, a question where you're between 30 and 70%, it's not unusual to go to very high numbers because there are a lot of students who figure it out during this brief discussion. I finish up with an explanation, and then the cycle repeats until class is up. And of course, the interesting part of this cycle is the discussion. I just don't stand there in front of the classroom waiting and just looking from a distance. No, I participate. I don't participate in the discussion because they won't even look at me or listen to me, but I walk around and I listen to their discussions. Let me tell you, that is so interesting because now you hear your students explain things in their words. I promise you that if you do this, you go, oh, that's what they're thinking. It's like getting a window into the brains of your students. All of a sudden, you see what's going on here. Before that, you're unaware of it. But by listening in, you become aware of it. I've heard students explain things in ways that are much more effective than my own explanation. Anyway, do you want to try it out? Baba, you're asking an interesting question. Let's address that later. First, answer my question. Do you want to try it out? Oh, come on. I thought you'd be enthusiastic by now. I'd like to see a little bit more enthusiasm. I've been warming you up for an hour now. 2 yeses. Is that all? We have 100 participants here. I want 100 yeses. Okay. Yes, okay, good. Now I see. Yes, that's it. Thank you, Juan Paulo. Good. Okay, I see. And I even see some exclamation points. Good. Okay, you want to try it out. I'm glad. Yes, and you'll get time to think, Sia. Okay, good. So I hope you all read. I asked Prabha and Nazri to send you 2 paragraphs on thermal expansion. Did you all read that? No? Did you forget to send it, Prabha? I'm just kidding. I'm just kidding. I didn't send out anything. I'm teasing you. But you know what that means. Since you haven't read about it, I'll need to lecture you a little bit about it. And I'm actually very grateful because the one thing that I miss when I do peer instruction is I miss the lecturing, and I love lecturing. So I get to do some lecturing to you. Okay, I'm going to talk about thermal expansion. Thermal expansion deals with the fact that hard solids like metal, this is a metal bottle, or wood, this is a wooden cup from Japan, or stone. I'm talking about hard metals, not, let's say, tissue or gum or a donut or anything. Really hard metals tend to expand when they get hotter and contract when they get colder. This is very important in engineering. If you've ever been in a train, as it approaches a station and slows down, you may have heard this clickety-clack sound as it goes from one section of a rail to another. And you may wonder, why don't they just jam the rails together so that you don't have this annoying clickety-clack sound? Well, if they were to jam the rail together, if it heats up, the rail would expand. It can't expand, so it buckles, and it'd be bad. Next time you go to an airport, and you park or a shopping mall, and you park your car in a concrete parking structure that has multiple levels. Next time you get out of your car, you close the door, look down as you walk. You'll see that the concrete building is built from sections, and that between the blocks of concrete, there is a layer of rubber. This is because the concrete expands and contracts as the temperature changes. And in your country, it's going to be pretty severe sometimes, given the heat that you have in Malaysia. And if they were to put the different sections of concrete against one another, each is typically on the order of, 6 to 10 meters. So you have these strips of rubber every 6 to 10 meters. They leave a little gap, and in order, not to have water and other things drip down, you fill that gap with rubber. You may be thinking, okay, that's interesting, but it really doesn't affect me. You're wrong. Next time you go to the dentist to have the dentist fill a cavity, imagine this. Imagine that the dentist would just use a metal, and metal tends to expand. Metals tend to expand more than any other hard material. If they were just using an ordinary metal to fill a cavity in a tooth, you'd be in big, big trouble the next time you drink a cup of tea, because the metal would expand much more than the material of the tooth, and you'd have a cracked tooth. So you may be wondering, why is it that hard solids expand when they get hotter and contract again when they get colder? Well, the reason is that in any hard solid is made up, anything is made up from atoms, but in any hard solids, these atoms are arranged typically in a pattern, and these atoms hold each other in place. I'm showing here a simple square lattice, but it could be different types of arrangement. The important point is all the atoms hold each other tightly in place. I'm showing an opening between the atoms, but you should imagine that they're holding each other. There's some sort of invisible bond that is holding them. And as they get hotter, the atoms move away from each other. So this is hot, and this is cold. Hot and cold. This is really all you need to know to answer my question. But you may be wondering, why is it that the atoms get further away from each other? The reason is that atoms don't sit still. They vibrate, they oscillate like this. And the amplitude of that oscillation is related to what we call temperature. So these are cold atoms, and these are hot atoms. So imagine you're sitting in an auditorium. You're not sitting in an auditorium, but imagine you're sitting in an auditorium. People to your left, people to your right. Each of you is an atom. You wouldn't sit still. You'd be shaking. And as it gets hotter, you shake more. And your neighbors also shake more. What does it mean, shake more? It means you need more space, and you push your neighbors away, and they push their neighbors away. So you can think similarly about the atoms too. And it's not just the 9 atoms that I've shown here, it's all the millions of billions of atoms that make up a solid. So cold and hot. Cold and hot. Questions, anybody? Thank you. I know I'm a brilliant lecturer, so thank you, Jeffrey, for reaffirming that. But one warning here. I am not going to hide this screen and then simply ask you, when solids get hot, they expand because A, atoms get closer together, B, atoms stay the same distance, C, atoms get further away from each other. That would simply be me transferring information to you and you regurgitating the same information back to me. Frankly, there's a lot of education that fits that pattern, but this is not what we are after here. So you better ask me questions, because I'm going to try and see if you can take this picture of atoms getting further away from each other when it gets hotter and closer together when it's colder, and apply that to a different context. So cold and hot. Cold and hot. Cold and hot. Come on, no questions? Once I ask my question, it's too late for you to ask me a question. Okay, so last chance. Would cold remain the same position? Okay, let me try to interpret that question. So, in other words, if you take a metal and you heat it, the atoms get further away. If you would heat it more, they would get even further away from each other. I don't have a slide to show that, but you can imagine they go even further. But then if you cool it down, they get closer together again. And so in other words, if you start at a certain temperature and you heat it and then go back to that same temperature, it goes back to where it was. Definitely, yes, that's a correct statement, Sia. Last 10 seconds to get a question in. Sorry, hot and cold. Hot, and you can also just unmute your microphone and ask me the question via voice if it's easier. Hot and cold. Wow, maybe you're all very good. Does the distance between the gray and black dots represent the distance for movement? Yes, and different materials have different amounts that they expand. So, metals, copper, gold, you name it, they expand more than, let's say, wood or stone or ice. Juan Pablo has an interesting question. Why does the middle dot not move? Juan Pablo, I'm going to give you an answer that you're not going to like. I want to warn you. Here's the reason. You can see it, right? The middle dot does not move. The reason that the middle dot not move is the following. I make my slides in Adobe Illustrator, and in order to make this animation here, I made 2 drawings. I made this drawing of the 9 black dots, and then I made another separate drawing of 9 gray dots. No, I turned it gray and I made a separate one, where the atoms were further apart, and then I put one on top of the other, and I put the middle atom on top, middle black atom on top of the middle gray atom. That's why the middle dot is not moving. Actually, it's a very good question. It's true. What I'm telling you is true. It's a very good question that you're asking, because that was a choice I made, right? I took this black atom here in the middle and I put it on the middle gray atom. But that was a choice. I could equally well have taken this atom here and put it on top of that gray atom. What would have happened then to this black atom? It would have moved in which direction? Assuming this is a clock, was 12 o'clock, 3 o'clock. No, it would have moved down and to the right. And this one, instead of moving to the left, would have moved down. And this one would have moved down twice as much. And that one would have moved towards the right, right? If I had taken this and put it here. No, because the ones out of plane move, there are other planes of atoms in front and in the back, right? A real piece of material is a three-dimensional piece. So anyway, the point I want to make is that a real material doesn't have 9 atoms. It doesn't have 9 million atoms, not 9 billion atoms, not 9 million billion atoms. No, it has trillions of atoms. So the position of any single atom doesn't matter. What matters is that they all get further away from each other. Good question, but not really relevant to our question, the question that I'm going to ask you. I think you're ready for my question, so let's go forward here. Consider a rectangular metal plate, and that plate has a circular hole in it. I have a drawing here of this plate. Now imagine that we take this plate and we put it in an oven and we raise the temperature and the metal expands. When the plate is uniformly heated, what happens to the diameter of the hole? I do not want you to put this in the chat, okay? Warning, if you put it in the chat, I'm going to ask you to turn on your video camera and your microphone, and you're going to have to give an explanation of why you had that choice. So nothing in the chat. When the plane is uniformly heated, what happens to the diameter of the hole? Does it increase, does it stay the same, or does it decrease? So take a little piece of paper and write 1, 2, or 3. And don't guess, think. Metal expands, and the diameter of the hole will if you've already written down something, ask yourself, how am I going to explain to somebody who has a different answer that I am right and they are wrong? So it's not about the what, but it's about the why. Who wants more time to think? If you want more time to think, just is what a rectangle or a square? This is an old question. Okay. So if you want more time to think, write in the chat now, wait, and I'll wait another little bit. Okay, nobody says wait. Okay, so you've all written down something. I should have thought of using Mentimeter or something like that, but that's okay. We can do without. So here's what I'm going to do. I'm going to put you in a breakout room. I'm going to put about 6 of you per breakout room, and go as quickly as you can into the breakout room and start a discussion. See first ask the room, what they have chosen, what answers they have chosen, and then ask for explanation. Oh, you chose 1, why is it 1? Or you chose 3, why is it 3? And see if you can convince another person that you're right, with your choice, defend your choice. And it's not about, guessing or anything. You need to think. Okay, here, I'm opening all the rooms. And I will call you back when it's time to come back. And if you're having trouble finding your breakout room, let me know. There should be a button, breakout room, at the bottom with your assignment. Okay, we still have a number of people who have not joined. Okay. Let's see if there are any rooms that have very few people. Yeah. Room 8. I'm gonna move. Oh. I'm gonna move this person out of 8 to room 12. Okay. Oh, room 1 has 1, 2, 3 people. Room 2 has 2 people. Room 3 is empty. We still have a lot of people here in the room. So unmute yourself and tell me if you need help getting into a breakout room. Room 5 has 3 people. Room 6 has 1 person. Does anybody need help? Oh no. Room 5. I'm trying to shuffle people who are alone in rooms. That's not good. There are just too many people who have not joined their rooms. 3, 8 is almost empty. This has 4 people. 10 has 2 people, 3 people, so that's good. Oh, I see. Okay. Do you want me to try to put you in another room? Here there are 2. Okay. Which was the room I was looking at?
We can't see the breakout room to join.
Okay, yeah, I'm going to put you in breakout room 11. Here. Hopefully that will work better. 3, 8 is empty. There's 3 people here. So, okay, good. So if you're still in the main room, you're missing out on the fun part of this evening. Well, evening for me, morning for you. Okay, there are 2 people in 14. I need more people in there. And there's only 1 person in 15. That's bad. So let's put the person in 14. And room 16. 1, 2, 3. So that's good. Okay, 16, 3, 15, nobody. 14, 3, 13, nobody. 12, 4, 11, 4, 10, 3. Yeah, tell me. I'm going to go into a few rooms myself too, just to see how things are going. Oh, this person is alone. Room 2. I'm going to join Nazri. Oh, but then I lose the screen sharing. I'm going to stay here. So are people in this room able to hear me?
Yes.
Okay, good. Do you want to talk about the answer?
Still thinking.
I beg your pardon?
Still thinking.
We can use this as a breakout room. Okay, Umawati, do you want me to try to put you in another room? I'm okay. So why, since we have a number of people here, I'm going to mute myself and I'm going to turn my camera off and take a mental break. But why don't you discuss this question? You may want to turn your camera on so that you can see each other when you talk. That makes it much more engaging. But I'm going to turn my and please discuss the answer. I'll be coming back in a few minutes.
Hello.
I don't know why everybody is so mute here.
Yeah. There are.
Juan,
Hello?
do you want me
Yeah.
to try to put you in another room?
Yeah, sure.
Okay. Let's see which room. I'm going to put you in the same room as Nazri is. Let's see. That's room 1. There.
Okay, thank you.
You're welcome. Is there anybody else here in this room, still in this room, who is paying attention? Hello? Oh, good. I'm going to close the room soon. Okay. 60 seconds and I'm closing the room. But I'm impressed that you're done. Okay, I'm going to get everybody back here. So it's going to take 60 seconds before there's a hard closing. So welcome back. I'm waiting for people to filter back. We have still a number of people in the breakout rooms.
The rooms are quite far away. It'll take time to walk back in.
They're quite what?
The rooms are far away. It takes time to walk back in.
Yeah. Okay, I think, yeah, 2 seconds, 1 second. Now they're closed. And people are coming back here. Okay. I think okay, good. Well, welcome back. You know, you probably notice it's very different, right? When you're talking to other people and you just get fired up. And I'm sure that many of you have forgotten that I'm not here to talk about thermal expansion. I'm here to talk about education. The answer to this question doesn't even matter. You've already made my point and shown how, teaching by questioning is very different from teaching by telling. I mean, imagine that I, instead of asking you the question, I had said, let's take a metal, let's apply what I've taught you rather than asking you the question. I would have the same little talk about the 9 atoms. And I said, Let's apply what I just told you. Angular plate with a circular hole in it. If you take one of these plates and put it in the oven and then turn up the temperature, the metal plate would expand and the diameter of the hole will, I'm going to keep you in suspense a little bit longer. I mean, you would have been sleeping through it. I mean, what is more boring than a rectangular metal plate with a circular hole in it? And look at you now. I'm sure that if I were to say, bye-bye, I really need to go to bed. I'm sorry, I'm tired. You would probably be emailing me tomorrow to ask what the answer to this question is. Isn't it amazing how we can reawaken the curiosity of the human mind? I was so happy to hear about the series being called Curiosity, because that is so important. You know, we're driven by curiosity. And isn't it amazing how when you take small children, like 5, 6, 7 years old, what is the one question that they keep asking over and over and over again? Put it in the chat. All small chat. The why, exactly. We're born to want to understand. It's a biological need. It's a survival mechanism. We need to understand how the world around us works. It's a sad fact of education that this intrinsic curiosity, this intrinsic drive to learn gets beaten out of us. And by the time I get my students, even at Harvard, in my class, they no longer are interested in the why. They're interested in what do I need to do in order to pass the exam? What do I need to know? The why is gone. But the good news is this. I have just shown you how easy it is to reawaken this curiosity. And trust me, if you can do it with rectangular metal plates, you can do it with anything, okay? So, you know, before I tell you the answer, I want to analyze briefly what happened here. I asked you a question, you thought about it, and then I had you make a commitment. Ideally, we would have done it in person, and you know, I would have had the fingers on the chest. And then I would have asked you, find a neighbor who has a different answer and discuss it with your neighbor. And in the discussions, in the breakout rooms, you externalized the answer. You had to explain it. And something interesting happened. What happened was that you move away from the answer or the fact to the reasoning. And that reasoning is important. If I had asked a question about electrical engineering, you'd have been thinking like an electrical engineer. If I'd asked a question about art history, you would have been engaged in thinking like an art historian. So what this method does is bring the thinking back into the classroom. But this is the most important point. You became emotionally invested in the learning process, because if I were to not tell you what the answer is, you would come after me and ask me what the answer is, even though as I told you already before, and I'm going to remind you, I am not here to talk about thermal expansion. I'm here to talk about education. So before I tell you the answer, you have to answer again what you think the right answer is. So put a 1, a 2, or a 3 in the chat. There are more than 5 people. Boy, it's a bimodal distribution. It's either 1 or 3. And it seems to be, it's pretty close to each other. Keep going, keep going. 2 says Mazur, and maybe with so many 1s and 3, it's the right middle road. Okay, so good. Yeah, I thought I gave a pretty darn clear lecture, and here you are. Half of you answers 1, and the other half answers 3. And there's one person who's wavering was a 2 here. Now we got another 2 there. You know, you should really have done the reading before coming to my lecture tonight. I'm just kidding you again. But you know what? You know what? You've actually made a really important point by the way you voted there. Because what is clear now is that, in a sense, you're telling me, Eric, your lecturing sucks, which is actually exactly the point I wanted to make, right? I mean, I transferred the information about the atoms getting further away, but it's not obvious at all, even after talking to each other. Unfortunately, I don't know the distribution of answers before. There's a pretty good distribution actually right now if the correct number of answers before you talk to each other was lower, and I suspect that was the case. So let me tell you, the correct answer is, look, everybody's paying attention now. Can I have a drum roll? The correct answer is number 1. Number 1. And you know, it's great to see that a reasonable number of you, I suspect that less than a third had the correct answer, because I've seen many different audiences vote on this. And if it gets to 50%, it means that about you know, probably a third of them had it. So we had a gain, but you know, it was good. Yeah, that's good. Okay. Now I don't want you to lie in bed tonight and, you know, at 2 a.m. and think, you know, awake because, you know, you haven't resolved in your mind this question yet. So let me take a few minutes of my precious time, and then I'll wrap up this talk. And I'm happy to allow a little bit of time for questions. If you have a jar of some kind of you know, mayonnaise or whatever, a hot sauce in the refrigerator, it's a glass jar with a metal cover, and the metal cover is a ring with a plate. You take it out of the refrigerator and you try to open it and you can't open it. What do?
Hit the bottom.
You heat the cover, right? And the ring will expand, and therefore it's easier to take off. And you say, well, you didn't ask about a ring, you asked about a plate. Okay. Let's imagine we have a plate like this, no hole. This is the plate, no hole. And now I'm drawing a circle on the plate. Can you imagine that? I have a plate with a circle on it. And I put the plate with the circle in the oven, and I turn up the temperature, and the plate expands. What happens to the diameter of the circle? The circle will get larger. You say, that's unfair, there's no hole. If there was a hole, then the atoms would expand into the hole, and the hole size would decrease, which is, you know, what quite a few of you said. Let me show you why that doesn't work. Let's imagine that we were all together in Malaysia someplace, and in person in a room, and I invite you to go outside, and we form a big circle holding hands. Each of these dots is one of us. Each of us represents an atom at the edge of the hole. And now I count to 3, and at the count of 3, we all move in we move in towards the center of the hole. What just happened to the distance between us?
There will be
It got
space.
smaller, right? We're closer together. We can't be closer together because we're shaking more and our neighbors are shaking more. We need more space, not less space. How can we make more space? Let's go back to where we were before. Well, we could remove a few of us, but atoms don't disappear like that. Or we can make the hole larger. You won't forget this. By the way, the last 2 explanations were explanations that were given by students, not by me. So this shows the power of listening to how your students learn. Anyway, I want you to note the following 2 things. My clear lecture, there were no questions until I insisted, wasn't that effective. And during the discussions, there were probably a number of you who went, oh, aha, right? It's in that discussion, and the data, right? The discussion promotes these aha moments. But there are higher learning gains. I've shown this. If you go to Google Scholar and you do a search on peer instruction in your own discipline, let's say peer instruction, electrical engineering, or peer instruction, mechanical engineering, or whatever, you will see papers that show how the gain, the normalized gain between pre-test and post-test goes up. There's such an abundance of data. It's just amazing. And also there's better retention, because once you've had this aha moment, it sticks. And even if you forget the fact, you know that you can think through it. I want to end here because I want to give a little bit of time for questions. You know, this was work that I did back, you know, like 30 some years ago. And in the meantime, my teaching has advanced and moved on. I still teach by questioning. But if you were to step into my classroom right now, it looks very different. Students work in teams. They work on projects, some of which is done, you know, with each other, planning on the computer and discussing things. Some of it actually building things, and at fair, showing it to others. Look at the smiles. Have you ever seen smiles in a lecture-based class on let's say, physics? I haven't. In fact, you know, once I started teaching this way, using projects and team-based learning, you know, I've had in my evaluation so many students saying how fun the course was. And I always thought, you know, is fun a good thing? And in fact, if you think about it, early in life, learning is fun. At the current stage in our careers, learning is fun because living is learning. So you start out thinking of learning as fun, and then as you go through class, through school, the fun decreases, and the curiosity disappears. And then somewhere at the end of graduate studies or college or whatever our highest degree is, we rediscover the beauty of learning and the curiosity associated with learning. It should always be that way. And it can be that way. Here you see students who are in their first and second year of college and who are not interested in physics, who are actually smiling. And they're not smiling for the picture. They're smiling because they're actually having fun. So I think it's important to think about learning as something that is intrinsic to life and must intrinsically be rewarding and therefore fun. Now, I don't have time to talk about all of this. It would take another 6 or 7 or 8 hours, and we don't have that time. But you know, I've recently started offering something that I call the Active Learning Incubator, or A-Link program, where essentially and I'm working with a number of universities. I'm lining them up now for 2027. But we work on a cycle of inspire, innovate, and implement. Inspire, you know, the faculty, I start with that. Then I work with them to innovate their approaches to teaching. And finally, you know, they start implementing. And then we form a new nucleus of faculty that can inspire other faculty to go through a new cycle of inspire, innovate, and implement. If you're interested in that, we offer a number of different programs, masterclasses, a studio, masterclasses which are 1 day, a studio which is, you know, a few weeks, and an academy which is actually a whole semester. And if you're interested, just email me at mazur@harvard.edu, and I'd be happy to discuss that. But this is what I really want to leave you with, because this is at the center of any of those programs. Education in the 21st century is not about transferring information. It's not about getting students to do what we do, right? The world has changed, and now there's AI, and AI can do many of the things that we struggled hard to be able to do. In fact, AI can do everything I ask my students to do in a normal class. I've changed my classes, but if I take the class I taught a few years ago, AI can do it all. I want my students to stand on my shoulders I want my students to solve the problems that I cannot solve. We want the next generation to solve problems that we cannot solve because the world is a mess. There are so many problems: war, conflict, energy, health, data security, you name it. Nobody in my generation, our generation, knows how to solve it. We need to equip the next generation with the skills to solve these problems. And the key to that really is sort of active engagement that you sort of briefly experienced, even though we did it in a breakout room and not in person. So I'm going to leave you with this, and I'm going to keep the slide up a little bit, but I'd be happy to take some questions, which you can either put in the chat, or you can unmute yourself, and I'd be happy to take a few questions. Not too many because it's late here and I'm getting tired. I'm stumbling over my words. But thank you so much for your engagement and for your willingness. Yes, Mohammed, it is a cookbook, and if students follow recipes, they're going to lose their job to this device. And right now, you see article after article in the Wall Street Journal, in the New York Times. In fact, there was one the other day that said that college graduates in the US, and probably this is true worldwide, are facing a very, very, very grim employment market. Simply because, you know, industry and others, why hire a college graduate if you can take an inexperienced college graduate student, if you can take a more experienced person to oversee AI and do the job that otherwise many more people would do. So happy to take questions.
Hello, Prof.
Yep, I can hear you.
Yeah, one here from University Putra, Malaysia. I would like to, you mentioned about employment, getting our graduate to be employed. Our focus, as you know, that in Malaysia we have launched the Malaysia Higher Education Blueprint 2026-2035. And the goal for the blueprint is to produce humanity-centric, purpose-driven nation builders. And one of the main aim in the blueprint is to produce humanity-centric, adaptive, and entrepreneurial learners. So we're looking at what you're showing is, I mean, what you I've been following you like forever. So and
I'm flattered.
thank you. And you know, the approach, the pedagogical approach that you have been sharing is very inspiring. But one of my concern is in terms of the curriculum itself, because we want our students to be to gain the experiences through by design and not by chance. Now, you know, how many of Eric Mazur there in the world, you know? We want to have more of Eric Mazur. So, you know, we want to have people who do this beyond teaching. And I mean, of course, from your incubator, perhaps that will be the one of the way that we can have to scale up the people that will do this. But my challenge is in my also I think in other universities is to transform the educators to be like you, for example.
Yeah, it is. I mean, let me first of all, this was yesterday in the New York Times. Let me show it to you. This is just one of many, you know, an account of young graduates face the grimmest job markets in years, and so, you know, and then the Wall Street Journal had one, and the interesting thing is that the unemployment rate for people without degrees is increasing less than the students who have a college degree. At first, I thought that this is the Harvard Business School did a study looking at it, and I thought, how can it be that the high school graduates, their unemployment rate is going up less fast than that of, let's say, a college graduate, like a Harvard college graduate? But the reason is that they can do things that AI cannot do. They can become a plumber or an electrician. They can use their hands. So I think that what you're saying is very important, because we need a call to action here in the age of AI. We really urgently need to think about the future of higher education and the need for higher education. If we don't do that, then we might very well become irrelevant. And people, if more and more of these articles appear that tell college students you're not going to find a job, what are they going to do? They're just going to say, I'm not going to go to college. I'm going to do something else. Maybe I'm going to go to a vocational school. In fact, I live not very far from a vocational school, which right now has a wait list that is longer than Harvard's wait list. It's crazy. So I think we are at a stage for the white-collar worker, the educated worker, that is pretty much similar to what the blue-collar workers faced when automation happened. Robots are to blue-collar jobs what AI is to us. And therefore, I think you said, what is going to happen to the curriculum? We need to think about the curriculum, and we need to shift away from content and more towards skills, which is transferable. And we need to not tell students you're not allowed to use AI. That would be foolish, because they're going to use AI later in their life. We have to find ways of integrating AI into the curriculum in a way that is meaningful. I just spent a year, I was on sabbatical last year, the timing was perfect. And I spent a year actually working precisely on this topic. And I launched a new course this year, which integrates AI in a meaningful way. And I'm so far very pleased with the results. So Maz, you have a question here. How can we help our students to see, understand, or know that AI is a tool to help them understand the context and content of the learning, not to let AI do the work for them? I presume that's what you mean here. Some students blindly become too dependent on AI, earn their degree. Yeah, so I think the best way for us to do this is for us not to give them things that can obviously be done by AI. We really need to rely much more on oral interaction with the students. I taught the year before last, I taught a class of 160 students, and I found a way of interrogating all 160 students. Essentially, the class is essentially one long oral exam, if you want. They work in groups, and they have to solve a difficult problem. They're allowed to use any resource they want, but after using that resource, and when they think they're ready, I come to the team that's working around the table, and I pick one person and I say, why don't you explain on the board how to solve this problem? And yeah, they may have used AI, but they're still responsible for being able to articulate the thought, right? And they won't have memorized it. And essentially, I take 5 or 10 minutes to listen to them. And I know right away whether they understand it, whether they've mastered the concepts, whether they have learned the skill I want them to learn. And then I move on to another table and 5 minutes and I do that together with a couple of teaching assistants. And essentially every week, every student at least talks one of these 5-minute blocks. And throughout the year, which is 2 times 13 weeks, because there are 2 semesters in the course. First of all, I know these students in and out, but every student actually has to verbally defend what they're doing, which is what is going to happen later in their life. They'll have to. So I think we're going to rely much more on oral interaction than we did before. Sorry, that was a long and a little bit incoherent answer because I'm getting tired, but I hope you get the gist. Let's see. Yes, different countries have different educational cultures. Totally right. You know, and let's talk about your second statement here, which is, you know, incoming not as well prepared. But let's first talk about different cultures. That's true. But I think, as I've argued before, the way people learn is not different. And also, one thing I've noticed, and I've traveled a lot to, you know, in Africa, in Latin America, in less developed parts of the world. And one of the things I've noticed is that talent is distributed equally everywhere. There are just as many talented people in Malaysia or Indonesia or Nigeria or wherever than there are in the United States. Opportunity is not. But the way to nurture talent, which is everywhere, is education. And you make a statement here about the preparation of the student. I actually find that students at Harvard come in with all the wrong mindset and often with very deficient preparation too. First of all, we have a very diverse student body. I get students from all over the world, including Malaysia, including, you know, Nigeria, Latin America. I mean, Harvard has a need-blind admissions policy, so they come from everywhere with very different preparations. And also, how did many of the students make it? Essentially by excelling at standardized tests, by excelling at the things that I actually don't care about, namely memorization and applying memorized information to past tests. However, I find that the diversity is actually a benefit. Right? Let's say that we have all the students at exactly the same, let's say that we've done this question about the hole in the plate with everybody being at exactly the same level. Very little learning would have happened. It's precisely because some people are a little bit ahead of others that the teaching is taking place. And you may say, well, doesn't that benefit the poor students at the expense of the better students? No. You know, after using peer instruction for a while, who were the students who were some of the most vocal advocates of peer instruction? It was the better students. And one of my better students said something that surprised me first, said, it benefits the learning because you're not just on the receiving end, but also on the giving end. And then I thought, yeah, who is the person who learns the most in any classroom? Any classroom. The teacher, exactly. The teacher. We learn because the act of teaching is a way of learning. So let's say you have a student who is more advanced than another one. It's not just that this student moves up to the level of that student. No, they both move up. They both move up. So it's a win-win situation. So I found the diversity in my classroom and the different preparation actually a benefit. Nazri, I hope that that answers your question. How can we help our students? Oh, I already answered that. How do we actually, okay, so Hafiz, that's a very good question. How do we actually get students to participate in group work online? I think the key here is one key is team-based learning. You see, learning deep down is a social experience. but we turned it into an isolated individual experience, right? We take students, we put them in a lecture hall, we lecture them, and yes, they're together with others, but they're not talking to others, so they might as well be alone. And online, it gets, of course, even worse because you watch a lecture online and you're just completely isolated. But if you do team-based learning, students need to interact with each other. In the classroom, it's great, but let me tell you, during COVID, I taught for a year and a half remotely. It was fantastic, and my students loved it because they had to work as a team together. They had to make projects together, and I had to think of new projects that you could actually do online, which took a little bit of work. But my class, which was a required class for engineers and pre-med, actually got close to a 5 out of 5 rating because students loved the class in a time of isolation where they're working together. And think about it, education is completely focused on the individual, and then we deliver students to society at the end of our education. And what is the biggest problem? The biggest problem is that students don't know how to work together. What is one of the biggest problems we face in our work? People, because we never teach people how to work together. So I think that we have a moral obligation actually to teach, to use team-based learning. And I promise you, if you engage in team-based learning, you'll actually find much better engagement, both in the classroom, in person, as well as online. A good book to start, a good place to start is to go to team-based learning. I'm going to type the URL in here, .org, one word. And the book written by Michael Sweet and, I forgot the first author, is really a great resource for implementing team-based learning. And I've seen it implemented in Bandung, Indonesia, and other places. So I know it works all around the world. The culture is not yet well aligned with this approach. Well, I think it's important to talk to people in the government to try to inculcate. I think that the countries that will manage, or the institutions that will manage to do that, that also will manage to convince, politicians that this is a matter of national survival in a sense, right? Especially now in the age of AI. I think it's important to radically rethink our education.
Eric, I would like to ask you this. In conducting questions, in throwing questions to your class, do you increase your total teaching time, or do you stretch out your curriculum?
No, I first of all, initially what I did to validate my approach is I kept the content exactly the same. But what I did was I didn't lecture, but I had the students read the book before coming to class.
Okay.
Right? Because at that time we didn't have video that the students could watch. So they read the book and they read my notes before coming to class. And they had to, because I wasn't lecturing. I didn't give them a choice, right? So if they would not read and they come to class, they would feel
lost,
shut out, because they couldn't really participate. So the total amount of time I would spend and total amount of time that the students would spend, I diminished the homework a little bit, because in a sense I put the homework before class rather than after class. And we did the homework in class, in a sense, by asking questions and addressing those questions. In later years, I became more and more convinced that I was focusing too much on content and not enough on skills. So I started to reduce the content and to put more emphasis on developing skills, problem-solving skills, teamwork skills, collaborative skills, ethical decision skills, building skills for their projects and so on. So I started moving from content to skills, because content, you forget it, right? I mean, if tomorrow you and I would have to go back to our universities and take the exams that we passed, 20, 30, 40 years ago, it become a disaster, right? And this is an experiment I've been wanting to do at Harvard. I've been wanting to have my colleagues from the physics department take each other's exam. No preparation because they already studied before. It would be a disaster. So what does that tell you? Why stuff people into, why stuff, content in people's head if they're not going to use it later in their life anyway? Whoever came up with such a crazy idea? And we've been doing it for hundreds of years. And now we may be starting to pay the price for it because we generate people who are not going to find employment. So this is why I think, all over the world, we really need to sit down and ask ourselves, what are we going to do in order to keep universities meaningful in the 21st century? Anyway, I don't want to leave you with a negative feeling, okay? Because I think there are many interesting things. And I found out that there's a huge difference between artificial intelligence and human intelligence. Human intelligence has sort of two ways of thinking, which were illustrated in Daniel Kahneman's book, Think Fast, Think Slow. We have a fast way of thinking and a slow way of thinking that engage different parts of the brain. AI tends to focus more on the faster way of thinking. And it's easy to ask questions of humans and questions of AI that yield very different answers. However, I think we need to work together to develop some sort of a co-intelligence. And the only way we can develop that co-intelligence is by training people how to work with AI. And I'm personally very optimistic about it. I think we can improve what we're doing. We can make things more efficient. We can improve productivity. And those countries and those institutions that figure it out before others are going to be the Harvards and the MITs and the other big schools of the future. You have an equal chance at that as the United States has or any other country.
Okay, thanks, Prof. For
Eric.
Eric, thanks, Eric. Thank you very much for cranking up our curiosity engine.
Great. Well,
it's been a very long 2.5 hours.
Yes, and you arranged a wonderful audience. So thank you so much, and thank you to everybody who is still here. I wish you a great day. I'm gonna get some rest.
Before we bid you farewell and good night, we'd like to have a group photo with you.
Yeah, absolutely.
Yes. So everybody, please switch on your cameras, please. Cameras, please. Cameras.
Now I see my audience.
Okay. Now everybody can put 2 fingers, 1 finger, 3 fingers.
On the chest, right?
On the chest, yeah. Okay.
No, it was 1, remember?
One. Okay. Shah, whenever you're ready.
Okay, ready.
Okay. All pages done? Okay. Thank you.
Anyway,
Okay.
thank you all.
Thank you, Eric. So if with that, we wish you a very good night and thank you very much again. We hope we can get in. We hope we can get in touch with you for further questions.
Absolutely. You saw my email, Mazur.
Yes.
Good
night and sweet dreams, Eric.
Thank you.
Okay,
I'll
thanks,
sleep
Eric.
well.
Bye-bye.
Thanks.
Bye.
Nazri will get in touch with you with the
Great. Bye.
Okay, bye.
Bye.
So we have
Thank you. Bye.
We have the attendance link in the message in the chat.
Attendance link in the message. All right.
Thanks.
Sorry for my wrong physics.
No, that's interesting one. I'll never forget the theory. impactful learning. Thank you.
Okay,
Thank
okay,
you.
bye, bye, bye.
Yeah.
Bravo, you teach the wrong answer.
I teach the wrong physics.
No, we managed to influence Prabha that the answer is number 3.
That's a favorite question from Eric Mazur. If you follow the talk, he will ask
Yeah.
you about this kind of. But I think the simple thing without physics or anything, just draw the circle on the balloon and then you blow up the balloon.
Yeah,
You can see the circle is increase.
Yeah, yeah.
That's
Oh,
it.
yeah.
Correct. Yeah.
Okay.
That-
Good
thanks a
day.
lot.
Good
Okay,
day.
bye. You have a nice day. You have a good day.
Yeah.
Bye.
Okay.